All right, if you're gearing up for your ARE PPD exam, you know there are some things you absolutely have to know inside and out. Today, we are going to break down 4 of those core concepts, the real bedrock of pretty much every single project you will ever touch. Okay, let's just jump right in.
So picture this. It's the classic challenge, right? You're standing there, looking at this blank canvas, just dirt, maybe some trees, a whole lot of sky. Before you even think about opening your software, before you have a single design idea, you have to understand the ground you're standing on. So, where do you even start?
Well, the answer really boils down to these 4 ideas. And listen, don't think of this as just some random list you have to memorize for the test. Think of these as the first 4 tools you're going to pull out of your toolbox, the ones that let you turn that raw piece of land into a site you can actually build on.
First things first, you've got to know the rules of the game, right? You need to know the legal limits of your playground. Before you can design a single thing, you have to know with certainty where your property starts and where it stops. This is all about the legal framework. And that's where we meet our first big concept, meets and bounds. Yeah, it sounds kind of old school, and it is, but it's an incredibly powerful legal tool. And the name, well, it actually tells you everything you need to know. Meets, that's all about the measurements, a distance, an angle. Bounds, those are the physical boundaries, like that big old oak tree, or the edge of a stream, or a stone wall.
So why is this so critical for your ARE exam? Because you are going to be looking at legal property documents, you're going to be looking at surveys, and understanding a meets and bounds description is how you actually confirm those property lines. And here's the bottom line. You cannot create a valid site plan if you don't understand this legal description first. It is literally the foundation for everything else.
Okay, so we've got the legal boundaries figured out on paper. Fantastic. But how do we take that piece of paper and translate it to the real world? We have to physically measure the site, get the scale just right.
And that, my friends, brings us to chaining. It's the traditional word for the simple act of measuring a straight line between 2 points. And while, surveyors today have all sorts of fancy electronic gadgets, the principle, and the name, comes from, believe it or not, a literal surveyor's chain.
Now look, for the exam, nobody is going to ask you how to use an actual chain. What you do need to get is the principle behind it, and that principle is accuracy. Chaining is all about the basis of physical measurement on a site. It's making sure that the distances on your drawings are an accurate reflection of what's really there on the ground.
So, we've defined our property in 2D, we've measured it, but let's be real. Sites are almost never perfectly flat, right? So now we've got to bring in the third dimension, height. We need to understand the topography, the ups and downs, and that is exactly where datum and benchmarks come into play. And I love this slide because it boils it down perfectly. Just think of it like this. The datum is the big abstract idea. It's the theory. And the benchmark, that's its real-world representative. The thing you can actually touch on your specific site. That's the reality.
So let's drill down on datum for a second. It's basically a universal reference plane. The classic example everyone uses is mean sea level. Think of it as the theoretical 0 point that allows everyone, on every project, anywhere, to measure elevations from the exact same starting line. It creates consistency.
And you better believe this is a big deal on the RE. Every single decision you make about grading, about drainage, even your building's finished floor height, it's all measured relative to that datum. You have to make sure water flows away from your building, and you can't possibly figure that out without a consistent reference for what's up and what's down. So for the exam, burn this into your brain. Everything ties back to a datum.
So, if the datum is this giant theoretical idea like sea level, how in the world does a contractor on site actually use it? Well, they use a benchmark. This is a real physical object. You've probably seen them, that little brass disc set in the sidewalk or a chiseled mark on a foundation, and it has a very specific, known elevation.
So the benchmark is the practical, on-the-ground application of that theoretical datum. When a contractor is setting the height for a foundation wall, they're not thinking about the ocean. They're referencing that physical benchmark right there on the site. And that benchmark, in turn, is tied back to the datum. Understanding that connection is absolutely key for any exam questions about construction.
Okay, so let's recap. We've worked through our 4 core concepts. We went from the legal line on a piece of paper to physically measuring it to understanding its vertical height. Now let's put it all together in a nice, simple cheat sheet for you.
Just remember the story, the logical flow. It always starts with the legal description, the property lines. That's your meets and bounds. Then you move to measuring its physical length. That's chaining. And finally, you add that third dimension of vertical height. And that's your datum and benchmarks.
And here it is, the whole shebang on one slide. This table is your ultimate takeaway. It neatly lays out each term, its definition, its context, and, most importantly, why it matters for the ARE. Seriously, pause here, take a screenshot of this. This is your money slide for final review.
So I'm going to leave you with one last thing to chew on. Now that you have these 4 fundamental tools in your belt, ask yourself this. Which one of these concepts, if you get it wrong, if you ignore it, could lead to the most catastrophic, the most expensive mistake on a construction project? It's a question that really connects these ideas to the real-world responsibility we have as architects. Something to think about.